Okay, so right triangle trig, a brief summary, and kind of putting it all in a kind of a matrix so we can kind of see some things. So basic, our functions, sine, cosine, tangent, cosecant, secant, and cotangent. The notation of that, the ratio, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, cosecant is hypotenuse over hypotenuse over opposite, and then secant secant is hypotenuse over adjacent, and cotangent is adjacent over hypotenuse. Okay? So first we want to think about the ratios in terms of coordinates. Okay? First we're going to talk about the ratios in terms of cosine sine. Okay? The ratios in terms of cosine sine. Let's think about that. We got tangent is really just the sine theta over cosine theta. Okay? So that's what tangent is. So I'm going to write these in different colors so we don't get them confused. Sine theta over cosine theta. Okay? And then we've got cosecant is 1 over the sine. We learned that. 1 over the sine theta. And then we've got secant, which we learned was 1 over the let's write a different color. 1 over the cosine theta, right? We learned that. And then cotangent is obviously just the flip of this, right? So it's just cosine theta over sine theta. Okay? So those are some trig identities that you're going to need to know. Okay? Then on top of that, we need to look at some ratios in terms of the coordinates, in coordinates of the unit circle that we've been working on, right? So it's crucial to see this unit circle that when we take the sine of theta, right? When we take the sine, let me move this over. When we take the sine of theta, we take the sine of theta, say this is theta, right here, then what are we looking at? Okay? We're looking at the opposite over the adjacent or the hypotenuse. Which one? Opposite over, that's right, hypotenuse. Okay, everybody.
That's right.
Good job. All right. So, when we talk about this sine theta, we're talking about the opposite over the hypotenuse. But when we're talking about it on this, we're talking about the y value over the x value. Okay? The y value. We're talking about the y value over the x value.
And that's at what? How many degrees?
Any.
Oh.
We're talking about the y value opposite over adjacent. Opposite over adjacent. Opposite over adjacent. The y over the x. Okay? That's what's cool about this. It works with any coordinate. X and y. So, what if I am asking you about the cosine of theta? Well, ca is adjacent over hypotenuse, right? So the adjacent is your adjacent leg. That's your hypotenuse. So the adjacent is your x value oh, I'm sorry. I don't know what. All right, let's start that again. Sine theta is opposite over hypotenuse. Opposite over the hypotenuse. What is this hypotenuse?
1.
1. So it's the opposite, or the y value over 1. Sorry about that. And this cosine is the adjacent value, or this value, the x value, over 1. So the cosine theta is equal to the y coordinate. The cosine theta is equal to the x coordinate. If you were to put it on not just a unit circle, but any graph. Okay? And then tangent theta is equal to opposite over adjacent. Okay? So opposite is talking about y. And adjacent, we're talking about x. Okay? So it's always, the tangent of theta is always the y coordinate over the x coordinate. Okay? So let's fill out this chart here, and we'll be done. So we have y over 1 for your sine theta. We have x over 1 for your cosine theta. We have y over x for your tangent theta. And when we look at cosecant, it's real simple. The cosecant is just flipped. So it's 1 over y. The secant is the cosine flipped. So it's just 1 over x. And the cotangent is just the tangent flipped. So it's just x over y. So now if I give you coordinates on the test, you'll be able to find the theta.